All right, cool. Uh, Enterprise Data Summit. How are you all doing? I am so excited for this presentation. Mike, who's one of the organizers for this conference, reached out to me not too long ago. He was like, I have a spot open for you. Your last session was really good. What can you come up with today? I was beyond excited to hear this for the enterprise kind of setting for data, because so much is happening in the data space. There's shifts, modern data stack, what? Streaming data, data contracts, zero ETL, all these different frameworks are really popping up right now. And what does that mean for the enterprise? We're seeing a big transition from things saying theoretically, this is what we could potentially do, to now it's actually being applied. And the big elephant in the room is large language models. All of a sudden, every company is an AI company. So this session, I really hope to bring the three smartest people I can get a hold of that are very popular on LinkedIn. So you should definitely follow them, because I think they're leaders in the space, really defining what this future of data looks like. So I'm beyond excited to chat about what are the new architectures in enterprise. So in one corner, I have Matthew Housley, who has a PhD in mathematics. He is a CTO of Ternary Data, but he is also the best-selling author of one of my favorite books, Fundamentals of Data Engineering. And through that process, he had a deep, deep understanding of what the data engineering space is. And I would honestly argue this is going to be a classic book that everyone references. Over next to me, I have Jazmia, who is beyond talented with the rare combination of having academic deep theory and also leading teams and applying it in industry. So she used to lead ML over at Motley Fool. She done research over at Stanford around NLP. She is currently an AI researcher at Microsoft thinking about reinforcement learning. And then she's about to start her doctor of philosophy over at Oxford for generative AI. You're looking at a leading voice and a future definitive voice in the AI space, which I'm really excited. And last but not least, I have Chad Sanderson, by far one of the most talented and prolific writers in the data space. If you've heard of data contracts, you've probably heard of Chad Sanderson. He has essentially, when he was working at Convoy, he was leading data platforms team there. And he was one of the first people to implement data contracts at scale. And through that, he's been diving and writing more and more about it. He started Data Quality Camp, which is the space to really start defining the industry of what data quality best practices is. So again, you have someone here who is defining what are the future data quality best practices. This is a very special moment, and I'm so happy you're here. Yes, say hello real quick to the folks, and just as a heads up, please ask your questions. We'll try to get to them during our chat.
Hey, folks.
Perfect.
Really
Awesome.
great to be here.
Yeah, very excited. Hi,
And
everybody.
it's kind of an intimidating group too, Jazmia. Frankly, I envy you being in the generative AI space right now. That's amazing.
I can't believe Matthew Housley just said that about me. Okay, that's cool.
So just to kick this off real quick, the first question I'm going to point towards Jazmia. You're uniquely positioned to speak about LLMs, given large language models, given your background leading ML teams and doing research in academia and industry. Why are companies rushing to put foundational models in production? And what do you believe is necessary for such an endeavor to be successful within an enterprise?
Yeah, so the tagline answer for that is FOMO. Nobody wants to be the person who misses out on what could potentially be a very lucrative space. And when I say very lucrative, I mean that if large language models of generative AI lives up to its promise, this can be more money and more opportunity than what we've been able to have in the past when we're talking about the IP of a lot of these large tech models. So you don't want to be left out of that. So that's why a lot of companies are like, okay, let's put all of our investment into building out some type of large language model capability so that we'll be one of the people who can make the answer to that when our users begin coming to us for that. The question, though, is whether or not it's at a place where it can become profitable. Right now, it costs a whole lot of money to be able to train these types of models. There are different rumors about how much something like ChatGPT can cost per day, but we're talking about billions of dollars potentially per year to train these very large generative AI models, the typical company will not be able to afford to keep that up without being able to bring in some revenue over time. And so it will be important for these companies to figure out ways to make it profitable. Is it by creating APIs for, if you're a very large company like, say, Microsoft, is it about making APIs to make it available for other people to be purchasing and buying into, kind of a B2B strategy? Will it be focusing on this B2C strategy, which is what we currently have, where individuals might potentially have to spend, however much money a month to be able to use a generative AI backed thing? That's going to be the question. But it's really about who can make it profitable, and whoever can, it's green pastures from there.
And I can imagine there's probably a lot of parallels between the whole digital transformation and enterprise, where all of a sudden people are having this FOMO of like, we need to be on internet, we need to have these digital tools. It's probably going to be similar with AI transformation. Do you see any parallels with that as well?
Oh, absolutely. I mean, one of the things that generative AI right now is reminding me of the most. I'm glad you brought up digital transformation, but I also want to go even further back in tech history to the .com situation, when everybody and their cousin wanted to have a .com website because they knew that the internet was going to be big. They just didn't know how. And so you have these instances of, multiple people just buying up like random domains because they're like, some company is going to want this domain and I can just sell it to the company and make some money on the offset later on. It's very familiar right now, this sense of, people don't really know how it's going to make money. They don't know what it's going to look like. They just know it's going to be a really big thing. And so, yeah, I mean, everyone wants to make sure they can go ahead and carve out their space, create and find a way to build a moat. So that way they have something that nobody else can also replicate, and then use that as an opportunity to be able to grow and progress and have staying power when this thing really gets large.
Awesome. Well, to kick it over to Chad, in numerous posts on LinkedIn, you have mentioned the need for data contracts for production large language models to be successful. Can you describe to the audience what data contracts are and why they're needed for a successful AI strategy?
Yeah, sure. Thanks, Mark. So in order to understand the need for data contracts, you first need to have a bit of an understanding of what the state of data infrastructure is today and how that impacts machine learning and artificial intelligence. The way that it works, generally speaking, is at the end of your machine learning infrastructure, you've got a training set, and that training set is composed of features. And ultimately, those features are used by a model to make some prediction about the future or to do some other sort of arbitrary task. All those data points are pulled in from other data sources. So it might be data within a data warehouse using a tool like Databricks or Snowflake, or it could be pulled from external data sources that are outside of a warehouse. So it might be first-party data, like a database like Postgres or MySQL, or it could come from a third-party API, or it could come from some SaaS application like Salesforce or SAP or something like that. At every point that data is moved from one step in that pipeline to another, there is a handoff. So I might be using the data in my database in order to run some production application, and I'm handing that data off to someone else who then starts using it for machine learning. The problem is, oftentimes, the way that some data owner is using that data and the point of that data is different from the way that a consumer wants to leverage it. And the more distance there is between the source of the data and the target, so how that data is finally being used in some pipeline downstream, the more opportunity there is for errors all along the way as teams begin to make locally optimistic changes to suit their individual use cases. This is constant, in my opinion. It's one of the biggest problems in data right now, and there's no solution for it. So this is where a data contract comes into place. A contract is essentially an agreement between a data producer and a data consumer about what is this data, how is it being used, what are the expectations of the consumer, and what is the semantic meaning of the data? What should it always consistently represent? And once that contract is in place, then a producer can make their own locally optimistic changes while also keeping in mind the downstream consumer as well. And that ensures that the truth, what the model is being trained on, does not suddenly change out from underneath it at any point in time.
And just to quickly clarify, because you've actually implemented this, what was the change? And because you had, from my understanding, you had ML models that were in production, right? That actually had dollar amounts to it.
Mhm.
When you implemented data contracts, like what was that transformation like once you actually got both sides working together?
Well, so there was a few impacts. Some of the impacts were monetary, and to your point, we did have a pricing model. We had around 25 machine learning models in production at Convoy, one of which was a pricing model. And once we implemented data contracts, we essentially cut out all the outages to that model, and it saved millions of dollars a year. But I actually think that that is a relatively small impact compared to the other things that the data contract actually did, which is it brought everyone, all of the stakeholders on a single pipeline, moving in lockstep with each other. So people began having conversations about the data and what the data meant and where it was going and how it was going to be used in a way that they were not before. In the previous state of the world, any issue with data quality was essentially routed back to a data engineering or data infrastructure team that was more or less operating as middleware between a data producer and a data consumer. And in the new world, that middleware essentially went away. So the data engineer could really focus on the job that they wanted to do, which is to maintain and grow and optimize that infrastructure, instead of sort of communicating between these two parties who really should be talking to each other.
Awesome. I'm going to switch gears a little bit and point it towards Matt. So there's this new shift in the data industry and the merging of batch and real-time data, currently be called zero ETL. That name is up for debate still because people are not really grasping it, but essentially this shift to merging batch and real time. A few months ago, you gave an excellent presentation at Data Council Austin, going to the technical implementation of such an architecture. Can you elaborate on what exactly zero ETL is and why it's worth considering?
Yeah. So I think the big idea here is that traditionally you need different types of databases to serve different workloads. And so two of your most typical workloads in the enterprise are a transactional workload that backs an application. So say you're tracking when users come in, when they click buttons, you're maintaining application state, and you have to handle a lot of transactions. You have to handle a lot of user activities across everyone who's interacting with your app. The other common type of database is one that's oriented towards scans. So in other words, if I want to do things like aggregations or analytics or statistics or train machine learning models, typically I need to look at large amounts of data all at once. So I might need, instead of updating individual rows thousands of times a second, I might need to interact with terabytes or even petabytes of data very quickly and just scan a massive data set. And so traditionally, the way we dealt with that is you would keep your set of data for the application inside of an application database, and then you would have to extract it and then dump it over. So extract, transform, maybe clean it up a bit, get it into a certain schema, and then load it into the target database that was optimized for doing analytics, scanning, statistics, those kinds of things. And it turns out there's another architecture you can implement where you capture the changes off of the source and then you stream them out to the target. And so by having two separate databases, you can kind of serve both of these use cases at once. The problem with that traditionally is that it's very, very complicated to implement. And so there are just a lot of moving parts. It's operationally expensive. You have to have engineers, you have to have ops teams to make sure that the system keeps running. What's happening right now is that complexity is beginning to disappear. The underlying complexity is still there, but this type of architecture is being offered basically as a service, so that instead of your engineering team having to deal with these details, Google can take care of it for you, or Snowflake can take care of it for you, or AWS can take care of it for you. And that means that you, as the application developer, can just focus on your application, getting the schema right, and then running your analytics. And so you take away this huge operational burden, which makes this whole type of system much, much more accessible. And so now you can take this zero ETL paradigm where basically you have the application operating, and then with a very short delay. So in other words, when I run my analytics queries, they might not quite be true real time. In other words, they probably don't reflect the state of the app down to the microsecond, but you're getting a picture of the world analytically that might be a couple seconds behind live data. And that is an extremely useful capability, and it really can change the way that we design applications, essentially.
That sounds exciting, especially that's something that really stuck out to me, was that a lot of this technology existed, but it's just been too hard to implement, especially when I talk to people about streaming data. The first thing I always get is like, it's not, the juice is not worth the squeeze. There's so much work going into it. And there's not enough use cases. But I would actually argue once this gets abstracted away, it becomes easier. There's actually be new use cases we don't even consider. And so in that vein, I'm going to switch over to Jazmia. Is, say for instance, a company had this zero ETL paradigm, and what would that look like under kind of like using AI and large language models? Would this actually power that up significantly?
Oh, absolutely. One of the major things that I think about is back when I was at Motley Fool, we tried building out a recommendation system that essentially was pulling in word embeddings to try to identify, which type of articles individuals might like. And then we had, your traditional, user matrix that was just full of like different features. And we were trying to map out what people might like. So essentially using a large language model to inform people on what type of articles they might like and which ones they might not like, and clicks and things like that. Streaming was one of the things that we thought about using, and in order to figure out in real time with somebody's clicks on a page of how engaged they are, whether or not we should give them a different recommendation. Ended up not moving forward with it for the reasons that you described. Something like what Matthew is describing here would make that 1,000 times easier for us. Now we're talking about, as opposed to running things in batch, and we're wondering, should we just run it in batch, every morning, and then grab how people, reacted yesterday to articles and see how they're going to like it today. Now we can begin making recommendations in real time. And now we can begin scaling the power of our model, which, for a lot of these types of models, they perform best when you are, interacting with them. They're learning models that are able to learn and transform as they're going on. I now have the ability to, take that information that I'm grabbing and be able to use it to continue to improve the different output that my model is giving to people. When we're talking about blowing that up onto a generative AI scale, something where somebody's like, hey, something has happened in the world today. You're not able to go to your generative AI and figure out what happened today. There's a lag in that time. Imagine it being able to grab and stream that information on a streaming basis when it comes to important news, major happenings that might have happened, or where you live and where your location is, and it's able to give you information that's important for you. And at that point, now we're bringing in recommendation systems. But again, like, imagine the capabilities there. Definitely could be huge to scale, and could be a very big deal, and can be one of the many answers to how can we actually make generative AI profitable, because now, you might spend some little extra dough on having a generative AI bot who's able to explain to you the news in real time, or things like that, versus just say something that can write you a really nice summary of an article that you just read.
Awesome. And switching gears, not switching gears, but switching person to talk about this. As I said before, zero ETL is kind of a misnomer, whatever the word is. It's not a clear kind of description. It's like a marketing buzz term, because there's still data pipelines related to zero ETL. Chad, how would data contracts fit within kind of a zero ETL paradigm?
Yeah. So in the data contracts world, the contract is actually pretty agnostic to the technology itself. It's a description of what do we expect the data to look like? What does it mean semantically in the real world? And what are the constraints on that data that always need to be true in order for us to trust it? So as an example, when Convoy is a freight technology business, and we worked a lot with trucks. And so if I have a definition of a shipment, and that shipment means, it's the distance between two cities on a map, I'm always going to have this sort of this lane or this load. Then there might be some data about that shipment that requires a certain set of constraints, right? I might always expect that shipment distance is represented in miles and not kilometers. I might always expect that the actual distance of that shipment is never less than 0 miles and never greater than, the number of miles in the continental United States, right? These are sort of definitions that are totally abstract from the underlying technologies that we're using to move the data. So if I want to use a zero ETL system, if I want to use Kafka, if I'm doing the transformation in batch, if I'm putting it in Snowflake or Databricks or something else, it doesn't matter. What I need is some tech agnostic surface that I can then translate those constraints to the text specific language where they need to be enforced. And that allows me to shift my technology as I need. So if I decide, you know what, I'm living in a batch world today, maybe tomorrow I need to move over to a zero ETL world, all of the beliefs that I have about my data and the requirements I have for my data remain true, regardless of which producer is enforcing them.
Awesome.
Can I just follow on here real quick?
Yeah.
What I'll add to what Chad said is that I think data contracts, like you're saying, are very technology agnostic, but they probably become more important in a zero ETL world simply because in traditional ETL, there's kind of this extra layer, right? It's not fully data contracts, but when I run that ETL job, it often makes some assumptions about the data. And if there's a problem with the data, then it will fail or it will generate some output that says, hey, this row might be wrong. With zero ETL, that intermediate isn't there. And so you're just getting raw application data. And so without contracts, it's actually a big risk of breaking your analytics very, very quickly undetected, which I think that's the worst kind of breakage, is one you don't see until someone comes to you and says, hey, I'm blind on my business processes. I can't see what's going on here. Or even worse, you're getting a bad number, right? And you're making business decisions on top of that number. Or going to the LLM example, you start feeding bad data into your training process, and who knows what that can lead to.
Yeah, that actually, so I had another question in mind, but now you just said the kind of like the dangers of it. I actually want to switch over to Jazmia real quick. Is that you have a lot of experience, not just like thinking about AI models, but actually putting them in production at scale. For enterprises, what are the unique challenges of AI in production that are really only present in their scaled up environment compared to like a startup?
Yeah, there are a couple that come to mind immediately. The first big one is perpetuation of biases, and that's one of the issues that can particularly run rampant in large language models. There has been, studies done on the fact that large language models, when they kind of push past their limit, so, I might have some restraints on my large language model to make sure it doesn't use certain words, or it doesn't, say things that we might flag as being biased. But once it gets pushed past its limit, those things fall apart quickly. It's a very quick reduction into the bottom of the abyss on large language models when you push it too much. And so that can be, especially when we're talking about enterprise, you have a larger amount of people who are interacting with the model who have the ability to push it past its limits very quickly, or at least in a quicker fashion than if it came out of a startup. And those can end up having catastrophic effects. So that's one of the big things. But the other big thing is, the level of hallucinations. And that's also attached to the bias problem. When you have a model that's being asked many questions that it didn't know it was going to be asked before. Now you begin having models that are answering things very confidently and incorrectly. And since you're getting so many questions and so many prompts at one given time, the people on the back end will miss some of these, incorrect answers unless they take the time to fully comb through, which means that these incorrect answers can continue to be perpetuated. So it's important more than ever to be thoughtful, to put up higher rails when you're in enterprise space, not letting your model get too creative with its answers. So that way it doesn't end up kind of causing those problems. And also, being more honest with your users and letting them know, like, hey, this is still kind of new. We're going to make some mistakes. If it does a bad thing, flag it, and we're going to go and fix it, and using that feedback to improve the product.
Awesome. And something I heard you talk about is like the scale of like people interacting with it. And that kind of aligns with the conversations I had with Chad multiple times about data contracts. And the funny thing is when you talk about data contracts, people really heavily emphasize the technical component of it. But as you said earlier, like the people on the data pipeline, the data producers, consumers were very, like the big benefit was them actually coming along lockstep. And so you have spoken to many large scale data teams about this. Can you share more about the lessons learned from solving this kind of scale of communication problem at enterprises?
Yeah, and that's for me, Mark.
Yeah, that's for you,
Yeah.
Chad.
Yeah, well, I would say that in general, data is probably 20 years behind software, not only in the technologies that we use, but in how we work together as a team. Generally, you've got, microservice-oriented architectures that were set up and designed to allow these individual product teams to deploy features very, very quickly and independently. But that fundamentally is not the way that a really good data team operates. And I think that oftentimes the data industry looks to emulate software engineering, and it leads to these massive data quality problems. So Bill Inman, back in the 1980s, was a huge advocate of data warehouse, and the data warehouse was originally intended to be an integration layer where we define our sources of truth, and we define, what are the key objects and entities that the business actually cares about. We unite all of the data sources for those entities upstream in the transformation layer, and then we vend that data to the rest of the business. And as the growth of data lakes and microservices and all these other technologies has increased significantly, we've started moving away from the concept of a warehouse and more towards, really embracing the lake, pushing data out to a bunch of different consumers, and then letting them, iterate as quickly as they possibly can and feeding that data into training sets. And all of that is happening with basically zero communication. So if you look at the way that software is deployed, especially if you're using tooling like GitHub, you've got concepts like PRs that have become, ubiquitous with deploying software, where essentially you have to have some human in the loop that is reviewing people's code, that's looking at diffs, that ensures that the right things are shipping and the wrong things are being fixed. But when it comes to data pipelines, we really have nothing like that. And so the purpose of a data contract is to try to bring this sort of iterative governance and ownership to the data world, which it does have some fundamental differences to how you would apply that same sort of thinking to software.
Awesome. And unfortunately, we're getting close to the end of our session. So to close this out, Matt, like I said, Fundamentals of Data Engineering, one of my favorite books. And in the last chapter, you go into kind of the future of data engineering. So building on that chapter, it's been like a year past now, so I imagine a lot of things have changed. What do you think leaders in this very audience need to start preparing for in this future state of data?
So one of the things we talk about in our last chapter is this idea that the spreadsheet is one of the most common interfaces that people use to interface with data. And frankly, people like me, I think people like all of us here, tend to disdain that practice, right? We're like, spreadsheets are terrible, they misrepresent data, the formulas are bad, but that's the reality. Like, it turns out a spreadsheet is a really nice interface for data. And so one of the things we talk about in this chapter is that something will eventually succeed spreadsheets as the new kind of idiomatic interface to data. Something will come along, some evolution. Maybe it's like a cloud-based spreadsheet that can scale. But I think just what's happened in the generative AI space in the last 6 months, last year, really changes this conversation. I can't predict what the new interface will look like. I don't think it will just be feed your data into ChatGPT and get something out. But I think we're going to see a fundamental paradigm shift in that kind of interface for a more dynamic, interactive, idiomatic way of interacting with data that somehow is connected with generative AI. I think the other trend I see is just going back to the zero ETL discussion. We'll see more real time, but not just the zero ETL variety of real time, but also types of real time that rely on more complex data pipelines and such. I know people have been saying that for a decade. People have been saying that since Kafka came out, but I do really feel like we're at an inflection point when it comes to real time data.
Awesome. And just to quickly close this out, I'm going to ask everyone, where's the best place to follow you so people can continue learning your great insights about data? So Jazmia, where's the best place to follow you at?
LinkedIn. Follow me on LinkedIn. I also have a website, jazmiahenry.com. So my name all squished together.com. Also follow me there, but LinkedIn's the best.
Chad.
Yeah, you can also follow me on LinkedIn, just LinkedIn in Chad Sanderson. And I have a Substack, which is Data Products. It's a newsletter. And I have a Slack channel. It's free. It's all focused on data quality. We've got over 6,500 members now, so you can get there, dataquality.camp/Slack.
Awesome. And Matt.
I think for now, LinkedIn as well is probably the best place. And I'm trying to stay on top of just announcing upcoming talks and things like this through LinkedIn mostly as kind of the center hub for everything I do.
Awesome. And I just realized every time I do a panel, I'm so excited about my guests, I forget to introduce myself. I'm Mark. At the end, you can follow me on LinkedIn as well. Also, I'm very active in Data Quality Camp with Chad. Also have a Substack, Scaling Data Ops, where I interview leaders, kind of like this conversation all the time, talking about the future of data. And real quick, shout out to all y'all for attending. Really appreciate you taking the time to listen to us talk about data as the nerds we are. Thank you so much. And thanks, Mike and the Solutions Monday team for having us.